Okay, so for polynomials, you can only have a polynomial if you do not have negative exponents or rational exponents. Now, rational exponents are fractions. So if you have any rational exponents, that means basically that you have a fraction exponent, which is just like this one right here. So if you have anything like this, or anything with a negative exponent, then that means that you do not have a polynomial. However, notice that on this one, the f of x, this one right here, equals x to the negative 3 plus x minus 1. That is actually the same thing as the second one right here, which is f of x equals 1 over x cubed plus x minus 1. The negative exponent is equal to 1 over x to the cubed. So neither of these two things are polynomials. So every time you see a negative exponent or you see an x on the denominator, so if it's in the denominator, you cannot have a polynomial. If it's a negative exponent, not a polynomial. Same happens with these two things. So if you have x to the 1/2 and you have the square root, those two things are the same. Now, I haven't gone over that too much in detail in class, but those two things are actually the same. So the x to the 1/2 and the square root of x are exactly the same thing. So if you see a fraction exponent or if you see a radical of a variable, then they're not polynomials. But what if you see something like f of x equals x squared plus the square root of 5? Well, then in that case, it is a polynomial, because the difference is that the square root of x is an unknown value, but the square root of 5 is not. The square root of 5 is a known value. Now, x, in this case over here, the square root of x, if x were a negative number, it would be undefined, or it would be a complex number, basically. So it's not really a real number. Therefore, it can't be a polynomial. But in this case, we already know that it is, because the square root of 5 is a real number. So you know that. Now, as for the second part, you have whether or not it's in standard form. So let's say that you have f of x, So you have f of x equals x to the second power plus 4x to the fifth power minus 3x to the seventh power. Now, this is not in standard form, because in standard form you have to have the highest degree first. And in this case, the 7 is the highest degree, the 5 goes next, and the 2 goes afterward. So what you're going to do is you're going to rewrite it as f of x equals negative 3x to the 7 plus 4x to the fifth power plus x squared. And in that case, now you have written the polynomial in standard notation. Now this is a power of 7, which you won't really get into this section because they're asking you basically cubic, quadratic, cubic, linear, or quartic. Now, linear is what we've discussed as, f of x equals mx plus b or ax plus b. So anything linear is f of x equals 3x plus 2. So anything with a power of 1. So if the x has a power of 1, so basically it doesn't show, that's linear. Now so this is linear. If you have a power of 0, so if you have f of x equals 5, that's constant. And the reason for that is because that is basically 5x to the 0. Why is that true? Well, the reason that's true is because x to the 0 equals 1. So x to the 0 equals 1, which means that 5 times 1 equals 5, and that's your constant. So that's why that is a power of 0 and a constant. Now, to be quadratic, we've talked about quadratics quite a lot in class, you have to have a power of 2. So that's your highest power. So you can have something like 2x squared plus 3x plus 1, or something like f of x equals x squared. Simply is just a quadratic. For a cubic, you can have f of x equals x cubed. So your highest power is going to be that 3. So if you have f of x equals 2x cubed minus 2x squared plus x, something like that, it's still a cubic because the highest power you have is a 3. A quartic is f of x equals x to the 4th, because again that highest power is a 4, so this is quartic. And that is what they're asking you to do in that section of problems, which is 17 through 22. And then the leading coefficient of all of these things is the number in front, so it's the coefficient of the variable that has the highest degree. So let's look at this right here. So you have this one is cubic, so you have the 2x cubed is your leading term because it's the highest exponent and it's the leading coefficient is going to be that 2. So the leading coefficient of this one is 2. Now if you had something like f of x equals 4x squared minus 3x cubed plus 5x to the 4th, first thing you need to do is rewrite that in standard form. So you get 5x to the 4 minus 3x cubed plus 4x squared, so that your exponents are in order from greatest to least. And then you need to identify the coefficient of your highest term, which is that 5. So that is your leading coefficient. So the leading coefficient here is 5. So the LC, I'm going to call it, is 5. And that is all you have to do. So this is a quartic, which is your type. So this is your quartic, your leading coefficient of 5, and it is now in standard form, and it is of degree 4. And that's all you have to do in that one. And if you have any other questions, please feel free to email me.